everyone. All right, this is going to be just a quick lesson today on predicting the products of a chemical reaction. Now this lesson, it follows the lesson on different types of chemical reactions. So first we looked at, if you remember, there were 5 types of chemical reactions that we looked at. The first one was synthesis, when 2 elements combined together to form one product. And then there was decomposition, when you had one compound breaking apart into 2. We had single replacement, where a single element would come in and replace an element that was already in a compound. So if that element was a metal, it would replace the metal. If it was a non-metal, it would replace the non-metal. And finally, we had double replacement reaction. And the double replacement reactions when we had 2 compounds and the metals switched places with each other, or the non-metals switched places with each other. It's the same end result either way, right? Oh, and the last one was the combustion reaction, when we have a hydrocarbon, which was a compound of hydrogen and carbon, and that reacted with oxygen in the air, and it always gave us the same 2 products, which were water and carbon dioxide. So today we're going to use that, and we're going to use these patterns to be able to predict what happens, what the products will be for a chemical reaction. So on your notes here, you have this equation writing. So please pause the video if this is not open in your OneNote, or if you didn't print it on paper. So just pause the video and get this page, and then we're going to go over it together. Right. So like I said, our goal is to be able to predict the products that will be formed in a chemical reaction by using the 4 patterns that we've studied last time. So what we need to do, right, is we look at the reactants, you look at the substances that you're given, and you find out which pattern does it match. Like, for example, if you're given just 2 elements, then you know this is going to be a synthesis reaction. So you can predict what the products will be based upon the reactants that are given to you and the patterns for chemical reactions that you've learned. So I'm going to do an example with you, and hopefully this will make it easier to understand, and that way you can come back to the video, you can pause it, and anything like that. So again, these are the types of reactions that we talked about, and I've just talked about them. So the synthesis, the decomposition, the single replacement, double replacement, and the combustion. And you notice, look at the reactant patterns. So the reactant patterns right here, you see that they're all different. So that allows us to predict what's going to happen, because we can identify which reaction is likely going to take place simply by looking at the pattern and which one it matches. Okay, so let's scroll to the second page, and here is an example, sodium sulfide, right? So Na2S, and this is all you're given. There's only one reactant. So what we're going to do is we're going to assign the letters A and B to each of the elements, right? So Na, so that becomes A, and sulfur, that becomes B. Right? And so then what we see is that the reaction becomes just like AB, and then the products. So we know that this pattern matches a decomposition reaction, because if you look back at the patterns that we talked about, there's only one pattern that has only one reactant in it. So you know this is what's going to happen. So if that is what's going to happen, then the pattern tells us that AB breaks down into A plus B. Well, A, right here at the very beginning, A, we said was Na, and B was sulfur. So we'll put them back in. So get your A and replace it with the Na, which is what it was, and the B replaces with sulfur. So we have the original reactant. It's given to us in the problem, and now we figured out what the products are. So we put it back together, right? Na2S gives Na plus S. And then the very last thing that we need to do is to balance the equation. And you see you have 2 sodium right here. So there's 2 sodium, 2 NAs in the reactants, and there's only 1 in the product. So we're going to write a 2 in front of the Na. So that gives us 2 sodium, and there's 2 here as well in the reactants, 1 sulfur, and 1 sulfur in the product. So that's it. This is your answer. You were able to predict what's going to come out of the reaction simply by knowing what you start with and by knowing the 5 or 4 patterns that we talked about. So here's another one. Calcium sulfide plus oxygen. Oxygen is an element that is always O2, right? And there's some elements like this, the diatomic elements. Those are hydrogen, and then nitrogen, oxygen, fluorine, chlorine, bromine, iodine. All of these guys are always with a little 2. And we call those diatomics when they're by themselves, right? So if you had an equation and the equation was calling for nitrogen, nitrogen would be N2. So this equation here, calcium sulfide, CaS, plus oxygen gives. Okay, so we're going to do exactly what we did in the first example. We're going to assign letters, right? Each element gets a letter. So A for Ca, B for sulfur, and C for oxygen. So what that looks like is this. AB plus C gives. So we go back to the patterns that we know. AB plus C gives. So we see this is a single replacement reaction, right? It looks like a single replacement. So if it is a single replacement, then we're looking at the element that's doing the replacing. So in this case, the single, right, is oxygen. Oxygen is a non-metal. So if oxygen, the single element, is a non-metal, it's going to come in and it's going to replace the non-metal. Always. A metal replaces a metal, a non-metal replaces a non-metal. So what's going to happen is in CaS, the sulfur is the non-metal. So oxygen is going to come in and take the place of the sulfur. Okay? So the C will come in, takes the place of the B, and the B is now going to be bumped off by itself. So we're going to get AC plus B. That's a single replacement. Well, now just put back your elements that you had at the beginning, right? We said that A was Ca. So this is Ca. C was oxygen plus B was sulfur. Now sulfur doesn't take a little 2 here because it's not one of those elements, right? So sulfur can be by itself. And oxygen doesn't get a 2 because it's not by itself, it's with carbon. So calcium, sorry. So remember, these elements, they always take a 2. They're diatomics, right? Diatomic elements when they're by themselves. So this is the product, CaO plus S. So take your reactants from the beginning, and now we have the products, CaO plus S. And the very last step is to balance the equation. So when we balance this equation, in the reactants, we have 2 oxygen right here. So that means that in the product, we need a 2 as well. So we write a 2 in front of the CaO. But by doing that, you get 2 calcium also. So then we're going to have to go back to the beginning at the reactants where we only have one calcium, right? We're going to put a 2 in front of the calcium sulfide. But now we messed up the sulfur. Now we have 2 sulfur also. So then we're going to go back again in the products and put a 2 in front of the sulfur. So we have 2 calcium sulfide plus 1 oxygen. We don't write, you don't have to write the 1, right? Gives 2 calcium oxide and 2 sulfur. And now everything is balanced. This is your answer. So the best advice I can give you for this is to take it step by step. Don't try to do 2 steps at once. Don't try to balance to do step 4 when you're doing step 3. You know, don't do any steps at the same time. Just take it step by step. Write, assign each element a letter. That's step 1. Then once you have it, A plus B or something like that, then look at your patterns. That's step 2. And you find out, okay, so what does it look like? And then in step 3, put your elements back into the product. Step 4, put it together and then balance it. So I've prepared a few practice problems for you. And I've separated into steps to help you out. I hope this makes sense and enjoy completing the chemical reactions. Thank you.